Lesson 8 is on slope. The first thing is rank the hills in order of their steepness from least to greatest. So if we look at which one of these is the steepest hill, to me it kind of looks like this one looks really steep. The third one maybe is the steepest. This one doesn't look very steep at all. But what we're looking for is a formula for slope. So what slope is, you're going to see it represented by a lowercase m. Slope is rise over run. And if we do those two calculations, the rise is our vertical number and the run is our horizontal number. So if we divide those two numbers, it actually gives us the slope of the line, and it will tell us how steep the line is. So the rise is always the vertical distance and the run is the horizontal distance between 2 points. So if we use that formula up here, instead of just guessing, I'm able to find the rise. So that's our vertical distance is 60 over 70. And I get 0.86. And here the slope is the rise, so that's again the 60 over 110. So that's 0.55. And this last one, the slope is the vertical number, which is the rise over the horizontal number. And that's 0.8. So when I look at those three values, the biggest number is the one that is the most steep. So it looks like this one is actually the one that is the most steep. This one comes in second, and this one would be the least steep. When we're looking at a graph on our Cartesian grid, we read from left to right. So when I'm looking at this graph here on the left, I'm coming across reading like a book, and I'm going to read, and I'm going to hit A first, and from A it goes up. So this line here has a positive slope. When I look at this one on the right, I'm coming across reading like a book, and I'm reading my line, and I come to C first, and from C to D the line actually goes down. So this line has a negative slope. Something else we can do for rise over run when it comes to a graph is we can look at the vertical rise and the horizontal run of a line segment. So I know that this point up here is at 4, but notice it doesn't always go, the line segment doesn't go all the way to 0. So the rise here, I'm just going to count these squares. This would be 3, and the run would be 2. So it's a good idea to, when you have a line segment on a graph, to draw a right triangle underneath it, and then we are able to more easily count the squares here. So we do rise over run. And down here, we would say, oh, that line has a slope of 3 over 2. This one over here, if I draw from C to D, if I draw a right triangle underneath, the rise is 2 and the run is 3. But we have to notice, and this is going to be hard to remember, when the line is going down, I'm going to have to say the slope is actually negative 2 over 3. And just remember the negative 2 over 3, I can write the negative in the numerator. I could write the negative in the denominator. Or I could write the negative right along the dividing bar here. So I can say negative 2/3 and it can be out front. As long as there's only one negative sign, then those are all equal to each other. Those are all negative slopes. So example 1. Calculate the slope of each line segment where possible. Notice the direction and how it relates to the slope. So when you just see a line segment on a graph, a typical thing we would do from A to B is write in or draw in the right triangle underneath. And then I would count. This has a rise of 3 and a run of 4. So I'm going to say slope of AB, the slope is rise, which is 3, and the run is 4. So I'm going to leave it like that. Instead of writing that as 0.75, that's a great answer. The slope of AB is 3/4. The slope here, so we're still going on the same formula, that the slope is rise over run. So the slope of CD, again, I see this long line segment, so something we often do is just draw in our right triangle. And then I'm able to count the squares. So 1, 2, 3, 4, 5 over 1, 2, 3, 4. So this one looks like it has a slope of 5/4, but you're going to have to be careful. This line is going down. So I'm going to say here the slope is -5/4. And honestly, quite often, or most of the time, we're going to put our negative sign with our rise in the numerator. Okay, the next one, from E to F, this is just a flat line. So when I look at the rise here is 0. But the run is 1, 2, 3. So what happens if you divide 0 by 3? You just get 0. So all horizontal lines have a slope of 0. And then the slope of GH, this one is vertical. It's a vertical line. The rise, 1, 2, 3, 4, 5, 6, 7, 8. So the slope here, the rise is 8. But the run, if I look at how far sideways this line goes, the run would be 0. So any number divided by 0 in math, you're not actually allowed to divide by 0. So you would get an error on your calculator if you type that in. You could try it and check. Therefore, we say this slope is undefined. And that will be true for all vertical lines. The slope will be undefined. So the horizontal lines, the slope is 0. It's flat, so the slope is 0. But I don't know, imagine that a vertical line is just so steep that it's undefined. Example 2, choose any 2 points to find the slope of the line. Okay, so I see a point up here, and I'm going to draw a great big line down, and I'm going to draw a great big right triangle. So let's say that's what I did. And I'm going to use my formula, rise over run. And I'm going to say that the slope, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going down. 1, 2, 3, 4, 5, 6. So I think the slope is -9/6. Something you should always do in math, if you notice that I could reduce this further to lowest terms and divide the top by 3 and the bottom by 3, I would get -3/2. So that would really be a nice final answer. I like the fraction, but I do think it makes it easier if you write it in lowest terms when you're looking at slope. Somebody else could have come along though, and what if somebody else chose these points instead? Let's say you choose points that are closer together. That has a rise of 3 and a run of 2. So I would have gotten the same thing anyway. Okay, example 3. A line segment has one end point, so it's a line segment. One end point is 4, 7, and it has a slope of -5/3. Find the coordinates of another possible endpoint. Okay, so if we have a point that is 4, 7 on a graph, so this is my x, this is my y. 4, 7, so 1, 2, 3, 4, there's 4. 1, 2, 3, 4, 5, 6, 7. Here's point A. That's 4, 7, so that's 7 over there. And then we're told that the slope is -5/3. If this is our rise and it's negative, it means you're going vertically down. And then if the run is positive, you're going to go sideways. So usually the denominator, you're going to go to the right. And if the numerator is negative, you're going to go down 5 and right 3. So from this point, I'm going to go down 5, 1, 2, 3, 4, 5, and right 1, 2, 3. So there is my possible other endpoint, which would be B. Okay, what is that point though? 1, 2, 3, 4, 5, 6, 7, and up 2. So that ordered pair, remember it's always X first and then Y. B would be possibly 7, 2. That could create a line segment in AB. All right, part B, one endpoint is -2, -1. So if we go to -2, -1, that is C. And the slope is 4. Okay, when we're looking at slope of 4, it's not that the line would be flat. It's not that it's vertical or horizontal. It actually has a slope of 4. So I need a rise though. I know it means 4, positive 4 means we're going up. And then I need a run. So if you don't have a number under here, it's always 1. So the run would be 1 to the right. So from point C, we're going to go up 4 and right 1. So it'd end up here at -1. So we go 1 to the left and then up 1, 2, 3. So -1, 3 would be a possible endpoint for D. And then here the slope is 1 over 5. So 1 over 5 means up 1 and right 5. So from -4, 2, if we go -4, 1, 2, 3, 4, and up 2, there's -4, 2. So that's E. Then our slope was 1/5. So up 1 over 1, 2, 3, 4, 5. So I think that's a possible endpoint F. We could go up 1 and over 5 again. That could be an endpoint because this line segment, if we continued it, it would all have the same slope. So F, what is that ordered pair? This would be 1 and up 1, 2, 3. So F, a possible endpoint could be 1, 3. Example 4, Sarah's on the soccer team and she runs every morning before school. One day she ran 5 kilometers in 20 minutes. Calculate the rate of change and interpret its meaning. So the rate of change is the same thing as constant of variation or the slope of the line. So we're going to do rise over run, but I wanted to do this example just so that you can see. Normally what we've been doing is the rise would be 1, 2, 3, 4, 5, and the run would be 1, 2, 3, 4. But I need to really make you aware that look at the scale here in the denominator. The length of this line segment here, the run, is actually 20 minutes. It's not just 4 squares, so you can't always just count the squares. You're going to have to look at the scale. And the scale is not necessarily the same on the x-axis as it is the y-axis. So this is a direct variation starting at 0. When I divide those two numbers, I get 0.25, or I could get 1/4. But since this is a speed, maybe 0.25 makes a little more sense this time. So the rate she is running, that's what we just calculated. And it's 0.25. That's the slope of the line. But look at it, it's kilometers per minute. You never have to wonder what the units are because they should always be written on your graph. So this is kilometers per minute, and that's her speed. Example 5, last one. The graph shows the volume of gas remaining in a car's tank. So somebody's driving around and this is the liters of gas and they are going down. So this has a negative slope. Calculate the rate of change or the slope and interpret its meaning. So if I do the slope, this point, it's really hard to see. What is that, 64? Is it 62? But it does, whenever you're not sure, hopefully you'll see the point here, that's 65. And down here, this height here is actually 5. So instead of just saying the rise is 65, another thing you have to be careful of, this line segment doesn't go all the way down here to the x-axis. It only goes to here, there. So we have a rise over run. And let's think about this scale. If this is 65, because I know by this ordered pair, and there's another one down here. If this is 65 and this is 5, how big is this rise? From 5 up to 65, so we've got a rise of 60. And what about our run? It goes from 0 over to 500. So you're definitely not just counting the squares here. This is worth 500 kilometers. So it's 60 over 500, and that is our slope or our rate of change. We have to remember that we do have a negative slope though here, so negative 60 over 500. If we reduce that, we could get negative 3 over 25, but I still think, because this one is a rate that we're looking at, a rate of change, we could also say it's 0.12 in this case, just because we have to interpret what this means. So this gas tank is losing gas at a rate of, so it's losing gas, there's the negative sign, at a rate of 0.12 liters per kilometer.